Hello, 7th grade algebra students, and welcome to lesson 1.1, solving simple equations. Yes, I know you've already had some exposure to this, but the numbers here are not nice and pretty. So we're going to give you some exposure to just a little bit more difficult of an equation, but still the same process. So first off, the goal is still the same as any other equation you've solved. We want to figure out the value of the variable. So basically we're getting the variable by itself on one side. Two properties that allow us to do this for addition and subtraction equations are the addition property of equality and the subtraction property of equality. Those were on your vocab from the last unit 0, so I know you're familiar. But basically with the addition property of equality, this is what allows us to add the same number to both sides of the equation without changing the value of it. And the subtraction property allows you to subtract the same number from both sides of an equation without changing the value of it. So let's try a few, and we'll start out with some nice little basic ones, and then they'll get a little trickier as we go. Let me get the zoom feature. All right, so our first equation is b plus 2 equals -5. Our goal is to get b by itself. Right now, this 2 that's being added to it is keeping it from being alone. So addition property of equality says that adding the same number to both sides of an equation makes an equivalent one. If I want to get rid of this 2 that's being added, I can add a -2, because 2 plus -2 equals 0, and then b will be by itself. But whatever I do to one side, I have to do to the other side as well, and a -5 plus a -2 is -7. And of course, we'll plug it back in, -7 plus 2, and that gives you -5, and we have checked it. I'm not going to check every single one of them. I just want to make sure you know how. So when you have an assessment, you can do that. All right, next one. Now I have g minus 1.7 equals -9/10. Yes, of course, you can look at this and just say, well, I want to add 1.7. Just like that other equation, instead of adding -2, you could have said subtracting 2. I'm just going to still be in the habit of changing all of my subtraction to addition by adding the opposite. So this is really, I'm adding a -1.7. To cancel that out so that g's alone, I can add a positive 1.7 because those are a zero pair. Zeros are gone. And when you take -9/10 plus a positive 1.7, remember you actually have to subtract the digits. And when you do that, you end up getting 8/10. And my greater digit's positive, so that would be a positive 8/10. If you were a little frightened, is this right? Then grab a calculator and type in 0.8 plus -1.7 or minus 1.7, and -9/10 will come out. So that is right, I promise. All right, next example. Now the variable's on the opposite side. It's not a big deal. I'm still trying to isolate this k. To get rid of this 3 that's being added, I can add a -3. Or I can subtract 3 because, yes, you know, it means the same thing. 3 plus -3 gone. And -3 plus -3 is not 0. It is -6. And I don't mind if you leave it like that with the k on the right. If you can't stand it, then go ahead and rewrite it like that. But I'm totally fine with that because k equals -6 and -6 equals k. They're both fine. Okay? Okay. Okay. Ooh, this is a good one. We have r minus pi equals pi. Now, pi, that's a symbol that we use to represent an actual number that we know the value of. R is the unknown. R is the letter. It's the variable that we're trying to figure out the value of. We're going to do this the same exact way. So this is r minus pi. I'm going to change this to plus a -pi. And if I want r by itself, just treat this like any other number. If this was a -8, wouldn't you add 8? So it's -pi. I would add pi. So -pi plus pi gone, and r equals. I have pi plus another pi, and think about the algebra blocks like this. When I had x plus x, I didn't have x squared, I had 2x. So if I have pi plus pi, I don't have pi squared, it's not multiplication. I have 2 pi. So r equals 2 pi. And if you think about the original equation, if you take 2 pi minus pi, that means you have 2 pi's and you're taking 1 pi away, aren't you left with 1 pi? Yes, so we know that we're right. So don't let those fool you or trick you. They're not that bad. Okay, fractions. Yes, for favorite. Everyone's favorite. So I'll add the opposite here. I want t by itself. Fractions are numbers too. We get rid of them the same way we do whole numbers. This is a negative 1/4. I'm going to add a positive 1/4 in order to cancel those out. T is equal to, okay, these are like denominators, which means I can just go ahead and add. So I have, when the negative's in the middle, we bump it to the top. -3 plus 1, which is -2, and bring over your denominator. Hopefully you see that and you go, oh no, that's not okay. It's not in simplest form. That's right. This means actually it's -1/2. Do we have to simplify, Mrs. Trombley? Yes, you have to simplify. Always. Okay, now we have another little decimal one here. So draw your line. Z's on this side. It's okay. This is a positive 5.6. I want it to go away. I'm going to add a negative 5.6. Or you're subtracting 5.6, however you want to look at it. So those are gone. Z is all by itself, just like it wants to be. And when you take a -8 plus a negative 5.6, maybe you want to line it up like this. They're both negative, so I get to add them normally. So I bring down a 6, 5 plus 8 is 13, and a negative plus a negative is a negative. So I get -13.6. And again, if you want to check, take 5.6 plus -13 plus, oh, wait a minute. Oh, sorry. This is right. It's 5.6. You go back to the original equation. If you take 5.6 minus 13.6, you will get a -8, just like we're supposed to. Sorry for that long pause. I got myself confused. I'm actually at my house right now recording this, and I haven't had all of my coffee yet. Okay, moving on to the next side of the page. There are, of course, multiplication and division equations as well. So these we're just dealing with the one steps of it all. And again, the properties that you've already been exposed to. There is the multiplication property of equality. There's the division property of equality. Just says multiplying each side by the same amount or dividing each side by the same amount produces an equation that is equivalent, meaning you don't change the value of it, it just helps you to solve it. So let's try some of these. All right, so for the first one, these are just basic that we've already been solving a little bit in our Unit 0. Let me zoom in here. All right, so this is a multiplication equation. We get that adding 5 isn't what's going to get the m by itself, because a -5m plus a 5 wouldn't give me m. Those are not like terms, so you can't do that. In a multiplication equation, we have to divide by the coefficient of the variable. So -5 divided by -5 is 1, and 1m equals m, and now m is alone. 35 divided by -5 gives me a -7, and voila, you are done. Another basic kind to review, I just have x being divided by 5, that equals -8. In order to isolate the x is being divided by 5, we can do the opposite and multiply by 5. Remember, the reason that works is because I can cross-cancel those 5s. You're left with x divided by 1, and any number divided by 1 is itself. And -8 times 5 is -40. And again, we are done. And the next one, I'm sure you recall from our lengthy note set in Unit 0, I have a fractional coefficient. Remember, when you have a fractional coefficient, all you need to do to get that variable isolated is multiply by the reciprocal of the fraction. Keep the sign. I want this negative multiplied by another negative so I can have a positive x. So all I did was flip it. So -3/2 times -2/3 is 1, multiplicative inverse, and I'm left with x. Now if you multiply this side by -3/2, you need to multiply this side by -3/2. Pop a 1 under it. -3 times -3 is 9. 1 times 2 is 2. And I, of course, would prefer you not to write them improperly. This would be either 4.5, or if you wrote 4.5, that would generally be just fine because it means the same thing. All right, here's that pi again. Hopefully you're not too hungry when you're doing this. So I have 6 pi equals pi times x. And the first thing you have to figure out is, what am I solving for? I know that pi is a symbol, but it's not what we're solving for. We want to solve for the letter. So I want to solve for x. Now, if there was a number in front of x, we would just divide by that number, right? Well, pi is a number, so I'm going to divide by pi. because any number divided by itself is 1. That includes pi. Pi divided by pi is 1, and x is alone. And if you have 6 pi divided by pi, we just said that pi divided by pi is 1, right? And 6 times 1 is 6. So x equals 6. Now if you look back up at the equation, 6 pi equals pi times x. Well, if x is 6, doesn't 6 times pi equal pi times 6? Yes, commutative property right there in action. So it works, I promise. All right, next one here. Okay, I have a coefficient that's a decimal. That's okay. We're allowed to divide by decimals. So I'm going to divide both sides by this. Aren't you glad you get to use a calculator now? I can old school it and show you what you would do. We would take 1.8 divided by 9/100ths. And remember, when you're solving that, you have to move the decimal over out there and move it over here. So I'm actually taking 9 into 180. 9 goes into 18 twice. 9 goes into 0, 0. There are no remainders. W is equal to 20. And notice, this is a negative divided by a positive, which makes it a negative 20. And if you don't believe me, take 9/100ths times negative 20. That's what you'll get, I promise. Okay, last one on this side right here, we have negative 3/4 n multiplied by negative 2. Okay, I have a fractional coefficient. All I need to do is multiply by the reciprocal of that fraction on both sides. Remember to keep the sign because I want a positive 1n. Negative 4/3 times negative 3/4 is a positive 1, and 1n is n. And over here, I have negative 2 multiplied by negative 4, which is 8, and 1 times 3 is 3. And of course, this is improper. Nothing improper allowed. So 3 goes into 8 twice. There are 2 left over out of 3. So 2 2/3 is what I would want it to say. Okay, now sometimes, when you look on the back side of this, you will need to simplify equations before you can actually solve them. So, and this kind of goes along with us learning about like terms and all of that. So when you look at this equation, there's a couple things happening to k. It's not a one step. So think about order of operations. Wouldn't you have to divide before you could add anyway? So what we're going to do when we see equations like this that aren't just one step is simplify on either side of the equal sign first, and then it'll turn into an equation we recognize. So here, you have to take 4 divided by 2/10. That means this. So I would move that decimal and move that decimal. And 2 goes into 4 twice. And 2 goes into 0, 0. So we actually get 20 for the result of that. So I'm going to rewrite this as k plus 20 equals 5. Now this is a nice one. This is what I'm talking about. All we need to do is add a negative 20 at this point, and we can see k is equal to negative 15. And if you take negative 15 plus 20, don't you get 5? Yes, it's right. Woohoo! Okay, next one. This time the variable's on the opposite side. It's okay. Just please remember that order of operations always applies. So I'm going to add the opposite here because I am just always doing that. And we're going to take care of this division before we can add anything. So negative 3 will equal piece by itself, and I'm going to add to that. It's negative 8 divided by 1/2. So if you take negative 8 and you multiply it by 2/1, because that is what we're supposed to do with fractions, we multiply by the reciprocal, you end up getting negative 16/1, which is negative 16. So this problem is really negative 3 equals p plus negative 16, and if you wrote p minus 16, it means the same thing. That's totally fine. To get rid of this negative 16, I'm going to go ahead and add 16. That allows me to get p alone. I have no words. I will keep them to myself. So negative 3 plus 16, that's a positive 13. And if you don't believe me, plug it in and check it out. It totally works. All right, just when you thought absolute value was done and over with, you will see it's never done and over with. So before we solve this, you just need to figure out what the absolute value of negative 10 is. And how far away is negative 10 from 0? It's 10 away. So this equation really means q plus 10 equals negative 2. Not too bad. It was more fierce than it looked. So I'm going to add a negative 10 or subtract 10 if that's what your little heart desires. And negative 2 plus negative 10 gives me a negative 12. And you are done with that one. Okay, now here we go. A lot of people will want to add those first, or you want to go ahead and like, oh, well, let's add a 1.3. Don't do that. Take care of this math problem first. It's kind of like combining like terms, except there's multiplication going on. You have to multiply these before you can do any addition. That's what order of operations says. So P equals, when you take a negative 1.3 times 2, it means you have 1.3 twice, right? So that is 2.6. Oops, I don't know why I wrote equals there, but there, now it's a plus sign. So it's a negative 2.6. That's what that equals. And over here, I still have my 7.9. To get rid of this negative 2.6, I'm going to add a positive 2.6. And P is equal to 9 plus 6 is 15. Carry the 1, 7, 8, 9, 10. 10.5. All right, the lesson is almost complete, but nothing is complete without a story. So it's math story time. I don't like to call them story problems. They are math stories. Doesn't it sound so much better? All right, so here we go. It's a science story. The melting point of Mercury is about 1/4 of the melting point of Krypton. The melting point of Mercury is negative 39 degrees Celsius. Write and solve an equation to find the melting point of Krypton. Okay. Whew. So we're not just figuring out the value, we actually have to set up an equation too. So let's look back at these words. It says the melting point of Mercury is, and I know that means equal, about 1/4 of, that means multiplication, the melting point of Krypton. We're trying to find the melting point of Krypton. We don't know it yet, so I'm just going to call that K. And the melting point of Mercury is what's equal to all that, and you're given that the melting point of Mercury is the negative 39 degrees. So if we look at the equation up here, well, it's in words, but we're going to make it an actual one. The melting point of Mercury, which is negative 39 degrees, is, which means equal to, 1/4 of, which means multiplication, the melting point of Krypton, which we don't know. That's it. That's your equation. Now to solve that, all I need to do is get rid of this 1/4, this fractional coefficient. I can do that by multiplying this by the reciprocal, which is 4/1, which is the same as 4. So if I do that to this side, I end up with 1K or K. And when you do that to this side, when you take negative 39 and multiply it by 4, I already did this ahead of time. You could type it in your calculator if you'd like. You get negative 156. And remember, this was all in degrees Celsius. I hope you enjoyed your story. I can't wait to see you tomorrow so I can tell you some more math stories. Have a good night.